In relativistic mechanics, we will cover two topics here. First is time dilation effect and next is time dilation is a real effect. So what is time dilation? In our day-to-day life, we do not observe time dilation effect because in order to see the time dilation effect, a particle must move with a relativistic speed, that is, its velocity should approach to c. So we don't encounter time dilation effect in our day-to-day life. But when we move towards the micro dimensions, then there is a possibility that time dilation effect can be seen. So now question arises, what is time dilation? Time dilation means lengthening in interval of an time. When a clock moving with a uniform velocity v relative to an observer appears to him to go slow by a factor under root 1 minus v square by c square, then at rest relative to him, then this effect we call it as time dilation effect. So diagrammatically, if we see here, we consider here two frames S and S dash. S dash frame is moving with a constant velocity v with respect to S frame of reference in the positive x direction. Y and YZ are parallel, Z and Z dash are parallel, and we have two observers O and O dash which are sitting at origins in frame S and S dash. In this case, we have considered an event arising in S dash frame of reference at some position x dash. So when the event arises at the position x dash, observers in both the frame of references S and S dash note down their time as t1 in frame S and as t1 dash in frame S dash. After few seconds, again at the same position the event occurs. So again the observer O note down the time of an event as t2 and observer O dash note down the time as t2 dash in frame S dash. That is, a clock is placed at a position x dash and an observer in S dash finds that the clock gives two ticks at time t1 dash and t2 dash, which he denotes as t0. So the event in which frame occurs, there the observer observes the proper time. That proper time he denotes it by t0, and that t0 is t2 dash minus t1 dash. Parallelly, the observer in frame S observes the time for both the events and note down the time t is equal to t2 minus t1. So we here use the inverse Lorentz transformation equations, and inverse Lorentz transformation equations are t is written as t dash plus vx dash upon c square whole divided by under root 1 minus v square by c square. That is the general equation. So here we write down the time t1 as seen by observer O in frame S as t1 is equal to t1 dash plus vx dash by c square whole divided by under root 1 minus v square by c square, and similarly t2 is written as t2 dash plus vx dash by c square under root 1 minus v square by c square. In both the equation, if we see here, the position x dash is fixed because the event is happening at the same position. So if we take the difference of both the equations, that is t2 minus t1, so we get here the same parameter, that is vx dash by c square, and minus vx dash by c square gets cancelled out. So t2 minus t1 comes out to be t2 dash minus t1 dash whole divided by under root 1 minus v square by c square. And t2 dash minus t1 dash is nothing but t naught, which is the proper time interval observed in the frame s dash where the event is happening. So t is equal to t naught upon under root 1 minus v square by c square. This is known as the time dilation equation. Now it is observed that time dilation is a real effect. Now how it happens as a real effect? This effect is seen that experimentally it was verified that new meson particles are created above the altitude of 10 kilometers from the Earth's surface, and these particles are created by cosmic ray particle interaction with the Earth atmosphere. These mu mesons, which are created at an altitude of 10 kilometers, they travel with a speed of 2.994 into 10 to the power 8 meter per second, or it is 0.998 c. These mu mesons are unstable and they decay into electron or positron within an average lifetime of about 2 into 10 to the power minus 6 seconds. So if we calculate the distance that the mu meson have traveled, that distance we can easily calculate by a simple equation, as we know that velocity is equal to distance upon time. So distance is nothing but velocity into time. So the speed which with the mu mesons are traveling, that speed is nearly equal to c, that is 2.99 into 10 to the power 8 meter per second, and their average lifetime is 2 into 10 to the power minus 6 seconds. If we multiply both the parameters, then the distance that the mu mesons have traveled, that comes out to be nearly 600 meter, or approximately that is 0.6 kilometer. So if we see the distance traveled by mu meson, that is hardly a 600 meter. So now the question arises, when the mu mesons are created at an altitude of 10 km, that substantial amount of mu mesons were observed on the surface of Earth. The question arises that how this mu meson reaches to the Earth's surface, that the distance is 10 km. So for that case, this possibility was cleared, this aspect was cleared by considering the time dilation effect. So the frame in which the mu mesons were created, that frame is S dash frame if we see from the previous article, and there the time obtained was the proper time, that is T naught, which is 2 into 10 to the power minus 6 seconds. So now we are going to calculate the time as seen in the frame S, that is the Earth's surface. So that is T is equal to T naught upon under root 1 minus V square by C square. So velocity we know that is 0.998 c. T naught is the average lifetime, that is 2 into 10 to the power minus 6 second. So the calculated time comes out to be 3.17 into 10 to the power minus 5 second. So if we see the time calculated using the time dilation effect on the Earth's surface, that time is more in comparison to the time 2 into 10 to the power minus 6 seconds in the frame where the mu mesons are created, which clearly indicates that time dilation happens time is dilated. That means the observer sitting on the Earth's surface, he sees the time dilated. So using this time dilated effect or time dilation time dilated effect, now the distance was calculated and that distance nearly comes out to be 10 kilometers, which clearly predicts that time dilation is a real effect. But this effect is normally observed in the micro dimensions only, not in the macro dimensions, because the particle should travel with the velocity approaching to c. If a particle travels with the velocity approaching to c, then only we can see the time dilation effect. So, twin paradox is also an example of time dilation, and our GPS system satellite, which is working, that also is an example of time dilation. Thank you.